you watch the other video that I just made and then this one, it's going to look like I just wore the same outfit 2 days in a row. It's going to be awesome. I'm that kid. All right, perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, okay, then it is what from the endpoints of the segment? Imagine that you have a compass. I got a hand compass. What am I doing here? Equal what? Yeah, it's equidistant. Because my hand compass says so, right? If you did it with a real compass, you'd get that that length is the same on both sides. Okay, I know that this length has to be equal to that length. Okay, equidistant. Okay, so here's your if then. You guys see this part right here in blue? If I meet these conditions, then I can conclude that information. Okay, so what if my picture looked like this? Can I say that this and this are the same length? Why not? I have perpendicular. Why doesn't it work? Why not? Oh, here, let me give you why. Have I told you that AY and BY are congruent? No. So can I say that these two segments are congruent? No. Do you guys see that I need both of these things to happen? All right, here's another one. Ready for another picture? Okay, if I were you, I would draw these. Oh, shoot. Okay, so what is happening? Okay, here's A and B. Here's my Y. Here's my X. Okay, can I say that AX and BX are congruent segments? No. Why not? Oh, here, sorry, I meant to say this. I know that those two are congruent. Why aren't those other ones congruent? Yeah.
Because line YX isn't a
Yeah, I mean it's bisecting, but is it making a 90-degree angle? Is it perpendicular? Okay, so I have to have both conditions to be able to say that this is true. Everybody okay with that? All right, perfect. So now we have the converse. The converse tells us that if our point is equidistant from the endpoints, of a segment, then it is on the perpendicular bisector. So here's the tricky thing. I could have it going like this. I could have it going like this. Okay, I have to know that this is perpendicular here to be able to say that these two are congruent. Okay, so this piece of information is in the wrong spot. It needs to be here. Does everybody see what I'm saying? That piece of information is in the, you need two pieces of information to conclude the third, okay? So you have to know that there's perpendicular and that something is congruent to be able to say the other pieces are congruent. I don't know that I explained that very well. You need two of the three, okay? Okay. Alternatively, if you had A, B, Y, and X, you knew this, you know this, you know this, you know this. What do you know about that angle? It's perpendicular. So you need two of the three pieces of information. Does that make sense to everybody? Okay, perfect. All right. You're so silly today. Okay, a locus. Do you guys see the root for location in there? Okay, that's from Latin. Okay, it's just the set of all the points that satisfies a given condition. So the perpendicular bisector of a segment can be defined as the locus, the location of points in a plane that are equidistant from the endpoints of the segment. All right, so this point is equidistant. This point is equidistant. This point is equidistant. Does everybody see? It's like the set of all of those points that are the same distance from my endpoints. Good? Okay. All right, we have to find the measure of TU and justify our steps. Let's start with some givens. What do we know? Okay, so TW is congruent to WV. What else?
Line UW is a perpendicular bisector of
Yep. UW, the line is the perpendicular bisector of PV, the segment. How do we know all that? Given. Okay, what else did they give us? They gave us a couple of other little nuggets. Okay, you're really close. Just change TU to a segment instead of a line. TU, the segment, equals 3x plus 9. And UV, or VU, the segment equals, oh shoot, it's not the segment, it should be the length, so no bars. Oh guys, don't tell anybody I did that. That's I know, that's why it's also hilarious. All right. All right, VU is 7x minus 17. All right, that was also given to us. It's on camera. Yep, that's true. You're not wrong. Okay, now what? I have to find the length of TU. Yeah, we're going to use the perpendicular bisector theorem to do what? What does the, hey, do we have two conditions? Okay, so our third statement has to do with a point being equidistant from the endpoints. So I've met two of my conditions, so now I know that the third is true. Does everybody see that? Okay, so the perpendicular bisector theorem is telling us that TU is going to be congruent to VU. Okay, these do have the bars because we're talking about the segments. Okay, I need an equation that I can solve. How do I go from a congruent statement to an equation? What do I need to do? If I know that they're congruent, what do I know about their measures? Okay, because of the definition of? Okay. All right, now what? Substitution. Okay, so I have an expression for TU. I have an expression for VU. I'm just going to pop them into my equation. Substitute them in. 3x plus 9 equals 7x minus 17. So that was my substitution property. All right, do you guys want to finish this up? All right, go. Okay, we're just going to finish up this proof really quick. All right. So, I want to get all of my x's on one side. So I'm going to subtract away my 3x. Now I have 9 equals 4x minus 17. That gives me, that is from my subtraction property of equality. Okay, adding over my 17 gives me 28. Nope. Haha, hilarious, 26. Equals 4x. That is my addition property of equality. Dividing both sides by 4 gives me 6.5 for x. That is my division property of equality. And then I have to make my substitution. So I'm substituting 6.5 into TU. So, 3 times 6.5 plus 9. 3 times 6 is 18. 3 times 0.5 is 1.5. 9 and 1.5 is 10.5, plus 18 is 28.5. That's it. Okay, I think that's as far as we got today.